Hello guys, welcome to another exciting tutorial on Code Depot about how we can efficiently interact with the pixels in an image. In the last tutorial, we have already learned how to read, show and write images to the disk using OpenCV, ImRead, ImShow and ImWrite functions. If you would like to get more information about it, then please check out the video displayed on the top right corner of the screen. So with that said, let's begin. Before we dive into the exercise and the code, I would like to share with you the significance of the particular topic. The fundamental building blocks of any image are pixels, which are nothing but RGB and channel values. In OpenCV, images are represented as NumPy arrays. This makes it easier for us to interact with the pixels in the images, and we can use NumPy operations such as splicing and many others to interact with the pixels. With that said, let's dive into the code. So if we go through the project directory, so this is a simple implementation where we have got three images. The first one is Batman, which is this, and then there is globe, and then there is selfie. Then we have got the particular script that we are going to use, which is setting pics.ocv.py. So let's go through the code, what is happening in the code. So first of all, we are importing the necessary packages. In this case, that is only CV2. And then we supply the image to the script. In this case, I'm using selfie.jpeg, which is this one. So as told earlier, in OpenCV, images are represented by NumPy arrays. So we get the height and the width of the image, and we use the particular functionality, which is shape. And then for reference purpose, we just show the original image. And then we move further and we grab the origin of the picture, the pixel, which is at 0, 0. So that would be particularly this pixel, which is in the beginning of the image. So we grab this particular pixel and then we print out its RGB values, and we do the same for a particular another pixel, which is at 20 and 50. So that would be around here, and then around here. So and then we print out the RGB values for that particular pixel, and then we turn this particular pixel into red. So we define the RGB value for this particular pixel and we turn it red. And then we go ahead and crop the particular image. So cropping is a very important operation. We can use it in two different applications of OpenCV. So right now we are just calculating the center of the center pixel of the image. So that would be normally width divided by 2 and height divided by 2. And then we move further and then we are grabbing the image pixels from the origin, that is 0 to cy, and then 0 to cx. And then we are showing this particular as top left corner TL, and we do the same for the other crops that we will see later in the execution. Here we are grabbing these particular pixels and turning them as green. So that is the top left corner of the screen. And then we are just showing all these images, and it is waiting for a particular key on the keyboard for closing the function basically. So this is all we have in the script. Let's go ahead and do the execution. So right now, as you can see, the pixel at 0, 0 has values of red, green and blue as these. So the pixel, okay, let me move these so that we can view the original image. So originally the 00 would be the pixel at origin would be this. So that has the value 161 178. We can verify this later. If we move ahead, if we go to the pixel which is at 5020, so that would be around here and then here, and it has a value of red, 193, green and blue. So yep, and then we turn this particular pixel as red, then we have this particular value here. So let's take a look at the other crops that we have done. So this is the top left corner, this is the top right corner, this is the bottom right corner, and this is the bottom left corner. And then we have the one in which we are turning all the pixels green in the upper top left corner of the image. So yep, we can try it for other images also. So that is all for the tutorial today. I hope that this tutorial adds value to your coding adventures. I will encourage you to try the code on your own images and do experiments with the code. If you would like to access the source code, then feel free to check out the video description for the URL. So with that said, until next time, keep coding and keep innovating.